Come around and check those 3 pages in your packet. 18, 19, and 22. You should also take out your reference tables and calculators for me, please. Thank you. Yes. Okay, you're going to put that a little bit on there and on the top.
Still want to see it so badly. Good for you.
All right. What I'd like to do is give you answers to those questions on those 3 pages, and then we'll see if you want to go over anything. I'm not going to put it up on the screen, so listen carefully. Here we go, page 18. Part A is positive 20 meters per second. Part B is positive 70 meters per second. And part C is positive 20 meters per second. Any questions on that page? All right, let's go ahead to page 19 then. Number 1 is 0 meter per second squared. Number 2 is positive 1.0 meter per second squared. Number 3 is 0 meters per second squared. Number 4 is negative 1.0 meter per second squared. Number 5 is 0 meters per second squared. And number 6 is positive 1.0 meters per second squared. Any questions on that page? That should have been pretty straightforward, right? Because it's just like what we were doing in class yesterday. All right, 22. No, everything on this page, 1 through 6, has only one sig fig because of the values on the graphs. When you read those numbers, they only have one significant digit. So I rounded all my answers to one sig fig. So number 1 is positive 100 meters. Number 2 is positive 90 meters. Number 3 is positive 5 meters. Number 4 is positive 50 meters. Number 5 is positive 30 meters. And number 6 is positive 40 meters. Again, everything rounded to one significant figure. Any questions on any of those 6? Because we did 7 together, so that's why I'm not giving you that answer. We did that one in class together. No questions? All right, you may use those pages to help you. You will need scrap paper, so I think you probably have room in your packet to do that. Let's take out our Chromebooks and have out your reference tables and calculators to help you as well, because you've got 3 calculations to do here, one of each type that we learned in section D. You may go ahead and take this quiz now for unit 3D, reference tables, calculators, your scrap paper, pen or pencil to help you. Good luck. When you're done with the quiz, you can put the Chromebook away and you need to grab your notebook. Keep the other items out on your desk. During the break, we'll have to take the quiz, okay? I'm sorry. You can, if you want. We're going to move right on to something else, though, where you'll just need those items. All right. Let's just take a quick look here at what was posted in our Google Classroom stream. So you can see for homework for tomorrow, you want to be studying what we're going to be talking about today and really the entire unit because this is the last section of the unit. So mid next week, we're taking a test on everything you've learned about. Everything, right? Because in this unit, we're talking about accelerated motion, but you need to be able to differentiate uniform motion from the last unit with accelerated motion in this unit. So you may see both types. Your test on this, of course, is going to be Wednesday next week, although what I'm doing with you today and tomorrow, the last section of Unit 3 will be quizzed on Monday. The task corrections for Unit 2, remember those are due Tuesday. If you have those, they go in the blue bin over there. And then for Tuesday next week, you have to have the review assignment for this unit completed, and it is the rest of the packet, pages 29 through 42. There's a lot there. Some of it's study guides, review of vocabulary, really to help you understand the concepts. And there's a lot of practice questions in there as well. So that way you can see what the multiple choice questions are going to look like, what the show work questions are going to look like. There's a really good variety on those pages. So you've got 5 days to get that assignment done. And you There is no written assignment for tomorrow, which means you definitely need to start working on that review assignment tonight. And it should be no issue because it's by the end of today, you'll know everything that's going to be tested. Okay? Any questions about that? All right, so all you need for our double period today, your notebook, your packet, reference table is going to be really important. Really, really, really important. So have that out today along with your calculator. That's also going to be super important, and pens and pencils. And what we're going to do now is jump over to our last presentation for this unit, which is about how do we do problem solving with word problems involving different forms of motion. Both accelerated motion, that's really the focus of this, but also you'll see some uniform motion problems interspersed. So we're going to review the problem solving method that we learned back in Unit 1 and we've been using for all of the problems that we've been solving. And then we're just going to practice it. Okay. And today we're going to expand the equations that we can use. And this is where you're going to really begin to see the power of the guess method, enabling you to correctly pick the right equation off the reference table, because it's not going to be as easy as, oh, we only know this one equation. That's the one I got to use. No, not after today. After today, you're going to have quite a few that you can pick from. And without using our guess method that we discussed, this is going to be very difficult. So we have the guess method to make our lives easy, and that's what we're going to be using all today and tomorrow. So we're going to use equations. I'm going to be giving you a bigger list of equations that can be used to describe motion, both uniform motion and accelerated motion. And then we're going to do a lot of problem solving. Both periods today and one period tomorrow and next week, and for units beyond. We're going to be solving problems today and tomorrow that involve times, displacements, all kinds of velocities, and accelerations. And of course, we're also going to do some dimensional analysis with each of these questions too, to check that the units on our answer match the units that were in the problem. So let's just quickly review the steps in the method. What's the first step to solving a problem in our problem solving method that we've been using? Find the givens, list our givens. That's the G step, right? We've been practicing these. I don't know if you have to write them down again, but let's just review. What is the second step after identifying the givens? Unknown. What's next? The equation. That's going to be the hardest part today, figuring out the equation. Now, if the equation is not solved for the variable that is the unknown, what do you do? What have we been doing when it's not solved for the unknown variable? The unknown variable has not been isolated in the equation yet. Do we just, Ian? Yeah, then you're going to do your algebraic manipulation, isolate the equation for the variable that you need to solve for. Then what do? Yep, and make sure in your substitution that you include the units. Without those units, you've lost half credit in the question on a Regents exam. And then what's last? Yep. Now, we say solve it. Make sure that your answers, of course, have appropriate units and sig figs. Every answer needs appropriate units and sig figs. If what I've asked you to solve for is a vector measurement, then you also have to include a direction on this answer, right? Because vectors have direction. Now, there is one additional step. We haven't been doing a lot of it lately, but we did start off the year doing some of that with these, and that's our check step, which we also call the dimensional analysis step. We're going to pick up doing that with all the questions we tackle today as well. Okay, so we're going to check if the units in our answer match the units in the problem. All right, so that is a duplicate slide from a previous presentation, just reviewing that with you because that's not new. It's just that's what we're using today to help us do the problem solving. What's new today are the list of equations that we have. So you need your reference table opened to page 6 in front of you, and we're going to check off a bunch more stuff here. These are the equations of motion. And you'll see on page 6 that there are 5 equations we need to check off on the page. Starting with the first one, you should have already checked off the equation V bar equals D over T. And then we also learned earlier in this unit the equation A equals change in V over T. The next 3 are brand new, and I'd like you to check those off. The third equation is VF equals VI plus A times T. The next equation to check off is D equals VI times T plus 1/2 times A times T squared. And then the final equation we can use to solve for different variables involving motion of objects is VF squared equals VI squared plus 2AD. Now let's go through what all those letters stand for. Remember that D, and we should have this checked off on the right-hand side of page 6, represents an object's displacement or the distance that was covered. We'll be measuring all displacements and distances in meters. Lowercase t, we should have that checked off as well, represents the amount of time over which the object was moving, and we'll be measuring that in seconds. Lowercase a stands for the acceleration of the object, and that is always measured in meters per second squared. Now we have VI and VF, which you should have added to the list on the right-hand side previously in this unit. VI stands for the initial velocity of the object, meaning the velocity of the object at the beginning of the time period in the question, before the object began to accelerate. VF, we added to our reference table, stands for the final velocity of the object, meaning the velocity of the object at the end of the time period after it has finished accelerating. V bar, we specified yesterday in particular that V bar represents the average velocity of the object, which can be found by adding VI and VF together and dividing by 2. And we added that to our reference table previously. Should have checked off V bar. And then we also have change in V, delta V. That stands for VF minus VI, which we added to our reference table earlier with the A equals change in V over T equation. We expanded that change in V to represent VF minus VI. So that's a difference in the velocities, not their average. All right, everybody have all that stuff checked off? All right, now we go to our packet, and let's turn to page 23. And really the big thing here is we need to practice what these problems are going to look like, okay? And of course, you're going to need reference tables there to help you because you don't have those equations memorized. I don't expect you to memorize them. I expect you to copy them off the reference table correctly. And what I'm going to do is I'm going to start by modeling what you should be doing in these problems. And then after I do a few with you, where I'm showing you what to do, I'm going to start to ask you questions about them as we go around the room. And then eventually I'm not going to turn you loose to start working in some smaller groups when then each group will put their complete solution on the document camera and we'll critique it. Meaning if we were to grade it, this is what the grade would be on a test. All right. So let's look at question 1. It says we have a car with a velocity of 2.0 meters per second. It's missing a positive sign on that. So please make that positive 2.0 meters per second at time 0. I'm going to circle that because that is given information in the question. And it accelerates at a rate of positive 4.0 meters per second squared for 2.5 seconds. Those are the 3 given pieces of information in the question. I'm going to underline what I'm asking you for, which is the velocity at time 2.5 seconds. Now we're going to go to the first step of the problem solving method, which is to list the givens with a variable. This positive 2.0 meters per second at time 0. Time 0 is our initial time, starting time in the question, which means this velocity is the initial velocity VI. So we write VI equals positive 2.0 meters per second. And I want you to be careful, do not drop any digits. As soon as you do that, you're probably going to lose points in the question for significant figures. So make sure that you're copying all the digits down. The next value I see is in meters per second squared. You should be able to quickly identify that without me telling you what it is, based on the units of that measurement. Those are the units of an acceleration, lowercase a, positive 4.0 meter per second squared. Likewise, this last value, 2.5 seconds. Seconds is our unit of time, lowercase t. Now notice in the question, I want the velocity at that 2.5 seconds, which is the ending time, which means I'm asking you for the final velocity, VF. Okay, so this is the harder part now. But thank goodness we have a list to look at that we can use to compare these 5 equations that we have checked off on our reference table. The equation we need should have a VI, an A, a T, and a VF in it. So we start at the top of the list, and I can see this equation for V bar isn't going to work. It doesn't have a VI, a VF, and it doesn't have an A. No good. This equation, likewise, isn't in a great format. This one here is perfect. It has the VF and the VI in my list. It has the A in my list, and it also has the T. So that's the equation I'm going to work with. I would not pick either of these 2 equations because both of them have a D value in them. I don't have a D in my list, so it's no good. So let's now copy the equation off the reference table that we are choosing to use. VF equals VI plus AT. And we ask ourselves, is this equation isolated for the unknown VF? Yeah, it is. So there's no algebra to do. We can go right to substitution with units. So VF equals positive 2.0 meters per second plus positive 4.0 meter per second squared times 2.5 seconds. Now the next step is to go to your calculator and solve that. So 2.0 plus 4.0 times 2.5. How many sig figs is my final answer going to require based on the measurements in this question? 2. Look at the answer on the calculator. I got 12. Did you? Does that have the right number of sig figs? Yep. So the answer is 12, but that is not the final answer. Because I asked you for a velocity, which means it must have a direction. What is the direction of this answer? Plus, positive. Make sure you put a positive sign on it, or it's not a velocity. Plus, it also needs units. What's the correct metric unit for a velocity? Meters per second. Now we have to do our dimensional analysis step. And the way we do our dimensional analysis step is by starting to recopy the equation that we substituted into. And now what we're going to do, I ran out of room here, so I'm just going to continue over here, is I'm going to determine using only the units of the measurements on the right, what units I should get for my answer. So based on this, I'm now going to change out the VI to just the units it was measured in. And I can see in my givens list, that is meters per second. The acceleration, change out the A, that should be in meters per second squared. And the time is measured in seconds. Now you actually have to show me step by step how to get to the final units in this question. How do you clean this up, in other words? Starting here on the right, we're going to combine these 2 terms. What happens when we combine those 2 terms? Talk to me about the math there, Nick. Not all of them, nope. What happens here in this second half of the equation? There you go, because this second cancels with just the square. Cancels just the square, so that's what we show, which means I have some number of meters per second added to another number of meters per second. And when I add a number of meters per second to another number of meters per second, I get a number of what? Meters per second. I'm just checking units, and that is what I expect my final velocity right there to be in. That is dimensional analysis, where you are deriving the units of your final answer. You're checking them out. Let's go to number 2. Same process. What is the displacement of a train as it is accelerated uniformly from positive 11 meters per second to positive 33 meters per second in a 20-point-second interval? So based on the information in this question, I see right now I have 2 velocities. You see that? One of them is before the acceleration, one is after. The positive 11 meters per second is what it's starting from. You see, it says from positive 11. That means that is our VI. This is what we're going up to. So that is our VF. And that value, seconds, is a time lowercase t. The unknown is the letter for displacement, which is lowercase d. So now we go to our equation list and notice that the big kinematics variable, which has not been included, is a. We don't have an a. You see that? Which equation in our list doesn't include an acceleration? Look at your reference table. You have it in front of you. You don't have to look at the screen. Which one doesn't include an acceleration? Logan?
V bar.
Yeah, so that's the one we're going to use. But remember, what does V bar stand for? Average. The average of these velocities. So we're going to figure that out in a minute after we do our algebraic manipulation, because the D is not isolated right now. You know what that equation for D looks like. What is it? D equals what? V, what kind of V? V bar. Make sure you put that bar over it. Has to be the average value. Now, we talked in quite detail how to get an average of two values. How do you get an average of two values? Winnie? Yeah, so add those two numbers together, giving you 44, and then divide it in half. What do you get? Yeah, so your average value is positive 22 meters per second. So even though it wasn't explicitly given, you should know how to get it. Like that, very quickly. So now we can do our substitution with units. So that is positive 22 meters per second times 20 point seconds. Now you're going to go to your calculator, solve it. I am asking you for a vector measurement known as displacement. I want to know what that answer is with proper units, significant figures, and direction. Do it on your calculator. Awesome, what'd you have? Excellent. I agree with that. Now, the last thing we're going to do is we are going to check the equation that we plugged into to make sure that we can get to the units we ended up with. What units did we plug in for V bar? Meters per second. What units did you plug in for T? Seconds. What happens now? The seconds cancel. Show it. You need to show it. It's a proof. You show it, which means what are the final answers for D? D is going to be in meters, and that checks what we have for our answer. Number 3, we have a car that starts from rest. Notice I'm circling that phrase, starting from rest. That's giving you a measurement, but I'm not writing it out in a numerical form. We'll talk about what that measurement is in a minute. It accelerates uniformly at positive 6.1 meters per second squared for 7.0 seconds. So I did circle 3 things of importance in this question. I want to know how far the car moves. Any idea what starting from rest is telling you as a measurement for my list? Think about it. When you start from rest, Grace, what do you think? What's 0? Which velocity? The initial velocity, VI, is 0 meters per second. This is your starting velocity. And when you're at rest, your velocity is 0. Okay. What is this measurement? Mike, can you tell me what the positive 6.1 meters per second squared is a measurement of? The units, meters per second squared, are the units of? Yes, so that is lowercase a. Talia, can you tell me what the 7.0 seconds is a measurement of? Lowercase t. Nate, what is my unknown letter here? D. How far means distance specifically, not a displacement. All right, time to now pick the equation. I'll give you a minute to look through the 5 equations we've checked off on the reference table. You don't know if I'm going to pick you to tell me what the equation is, so take a moment, look them through. Start from the top of the list. Kayla, you think you have it? That is the correct one because we don't have a VF in the list. So that's the one you're going to go with. So the equation to select is D equals VI times T plus 1/2 times A times T squared. Very good. Now, is it isolated for D? Yep. So you can go right to your substitution with units, where VI is 0 meters per second times 7.0 seconds plus 1/2 of positive 6.1 meter per second squared times 7.0 seconds. Now make sure that 7.0 seconds is surrounded with parentheses and then put your square outside of it. Otherwise, if you just write 7.0 seconds squared without the parentheses, you're only squaring the unit and not the number 7. Now, let's see if you can simplify this at all. Do you have to type in 0 times 7 in your calculator? No, this is going to drop out. So I'm just going to exit out so I ignore it moving forward. Now you're going to solve it, getting an answer with proper units and sig figs. You will not have a direction on this answer because distance is a scalar measurement. I would encourage you to type in 1/2 as 0.5. That's not the answer to the question. It is not 149.45. What should the answer be? Logan?
150.
There you go. 2 sig figs because of these 2 measurements. The 1/2 is not a measurement, so we ignore it. Now, the last thing we need to do is our dimensional analysis step. And this is the equation that we need to check. And we have to plug in all the units for everything. So, Ellie, what units do we have for VI? What are the units of VI? Just the units. I don't do any numbers in this step. Meters per second. Sophia, what are the units of T? Good. We keep the plus. Does the number 1/2 have a unit? No units. We ignore it. This is all about units, not numbers. Ignore it. What are the units of A, Christian? The units. Thank you. No numbers. Grady, what is the unit for T squared? T squared, seconds squared. Now, what happens here, Gabriella? Okay. Yes. So that gives me some number of meters added to another number of meters, and you have to show that. So if I add a number of meters to another number of meters, I'm going to get a number of what? So the final answer is in meters, which checks. I don't care about numbers. There are no numbers in this. It's just letters. Think of it as an algebra problem. No calculators for that. All right, number 4. We have an airplane that must reach a velocity of 71 meters per second for takeoff. If the runway is 1.0 kilometers long, what must the constant acceleration be? How many of you have been on an airplane before? Okay, I have a question for you. Is the airplane moving when you get on it? Okay, that's a piece of information you need to know in order to solve this question. If the airplane isn't moving before you get in it to head down the runway, what do you know? You know that. It's not moving before it takes off, before it's going to try to take off. That's a piece of information we expect you will know. Now, what is this 71 meters per second? Matt, what is that? So what would you call that in terms of the physics variables that we have listed here on the reference table? Yes, so that is your VF. Grace, what is this 1.0 kilometer value? That is a distance D. And Mike, what's my unknown? So lowercase a. All right, we have one small problem before we look for an equation, and that is with the D value. What units do we need D to be in? Meters. It's in kilometers. We have kilos somewhere on our reference table, don't we? We've learned about that previously. Where do we find it? First page. You just have to change out. What does a K mean as a number? 10 to the third power. So just change it out. 1.0 times 10 to the third power meters. That's all you have to do. Okay, next step is to look for the correct equation on page 6. VI, VF, D, and A. VI, VF, D, and A. Take a look at that page. Which of those equations would be the right one? Do you see a T in this list? Okay, so that's going to give you a hint here. Bassem?
VF squared is equal to VI squared plus 2AB.
Yes, that's it. That's the only one that doesn't have a T. Very good. Now, there's the, oops, I circled the wrong one. I want A. I want the A. Can you move it around so it's solved for A? Gotta do the algebra. I don't need to see all the algebra. If you can just tell me what the final equation is for A, what does A equal when I move it around? This is what we practiced back in Unit 1, if you recall. That's why we practiced it, so we can just use it here. Who could tell me what that equation for A is going to be? Ian? Excellent. Now we're going to do our substitution with units. So A equals 71 meters per second. That quantity gets squared. Minus 0 meters per second. And that quantity gets squared. All over the quantity 2 times 1.0 times 10 to the 3 meters. Okay, before you go to your calculator, let's use our noggin a little bit. What is 0 squared? 0. This number minus 0 means I can ignore this part. So guess what I'm going to do? Put a little X through it so I don't even think about it. I don't go to the calculator to do that. Now, before you go to the calculator, there's one more thing I want you to think about. What is, in your head, 2 times 1? 2. Oh, very good. See, I knew you could do that in your head. 2 times 1 is 2. So the denominator is really 2E3. Don't type in the 2 times 1.0 E3. Type it in as 2E3. It will save you the headache of getting a wrong answer on your calculator. That is 1,000 times too big. Go ahead and work that out on your calculator then. So all you have to do on your calculator is 71 squared divided by 2E3. Right? Using your scientific notation key, 2E3. Not 2 times 10 caret 3. That's going to give you a wrong answer as well. How many sig figs do we need on this? Look at the measurements given to you. 71 and 1.0 times 10 to the third. How many sig figs do they have? 2. Round your calculator answer to 2 sig figs. What is it? Ian? Okay, we need to add one more thing to it. Yes, because acceleration is a vector. So what is it? Positive, that's right. And that makes sense, right? Because wasn't the airplane speeding up as it went forward down the runway? Okay. Take your break. When you come back, we'll do our check step on this. Just put the foot down on the door if you're heading out to use the restroom or grab a drink. Just put the foot down on the door, otherwise you're going to get locked out. All right, let's keep going. So we are on the check step now for this equation that we plugged into. So what we're going to do is just plug in on the right-hand side to see if we can get to the same unit for acceleration that we have here for this answer, okay? So what is the unit for VF? Mike? Meters per second. And we have to surround that with parentheses so that way we eventually square it. Now, what's the unit that we had for VI, Christian? Yep, again, surround that with parentheses and then put your square outside of it. We're going to ignore the 2 because it's not a measurement, doesn't have any units. What about D, Sophia? What's the D unit? Meters. Okay. So now what you're going to do following order of operations is you're going to square those 2 values. So the square distributes in the top and the bottom. So that's meters squared over seconds squared minus some number of meters squared over seconds squared all over meters. So if you subtract a number of meters squared per second squared from another number of meters squared per second squared, what do you end up with? A number of what? Oranges? Meters? Not just meters. I have a number of meters squared per second squared being subtracted from another number of meters squared per second squared. What do you get? Yeah, you're still going to have meters squared per second squared. So we're going to simplify that. Meters squared per second squared over meters. Now what happens? Remember, you got to show me the steps. What happens now? Yep, so that square cancels with that meter. And what am I left with? 1 meter over seconds squared. And is that what I wanted? That's what I had there. So it checks. Okay, you have to be able to do that yourself, showing me all those steps. Let's go on. Number 5. You're going to do the whole thing now. One person is going to do each step of this. Who wants to get us started by reading the question aloud while the rest of us circle and underline? Who wants to read it? Ian, go for it.
An airplane accelerates down a runway at 3.20 meters per second squared in 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff.
Excellent. Okay, so Talia, I need a given piece of information for this airplane. Is good. Bassam, another given.
For time,
Is
32.8 seconds.
so T is 32.8 seconds. Nate, what's the third given? It's an airplane taking off down a runway. You've been on an airplane before, right? No? Okay. Is the airplane moving when the passengers get on it before it takes off? Okay, so what else do you know?
It's
Is?
0 meters per second.
There you go. All right. Ellie, what am I looking for? What's the unknown? So what letter? D. Okay, now we go to the equation step. Sophia, we're up to you. What equation's the right one to pick from this list? Yes. Last night I was tutoring a student from Niskayuna High School whose teacher did not teach them to list the stuff out. And what did I spend an hour doing with him? Helping him list the stuff out so he could pick the equation. That was his thing. He could not. He was failing all his tests because he couldn't pick out the right equation. As soon as he started listing them out, he didn't need me anymore. I was like, congratulations. Best of luck to you. He was fine. He doesn't need me anymore. Okay, that's what you got to do. As soon as you do it, you're going to be fine with this for the whole year. But if you don't do that, it's going to mess you up. All right, it is isolated for D. So now we do our substitution with units. Repeat of earlier today, right? When they tried to come over the PA like 10 times. Okay, do you have to worry about the 0 times the 32.8? So just do the second half. Remember, type in the half, not as a fraction, as 0.5. You know a half and 0.5 are equal. It will save your calculator a ton of headaches from mistakes. And we're going to go to our final answer up here with proper units and sig figs. It is a scalar, so we do not want a direction on it. Don't forget to square the 32.8. Right, there's a square on that. That's the other common mistake with this question, is people forget the square on the t at the end. Haley, what did you get for this?
906 meters.
Did you forget to square this? You should have typed 0.5 times 3.20 times 32.8 squared. Okay, how many sig figs do I need? Mm-hmm. There you go. And the units, did you tell me the units before? Just meters, that's right. Okay, let's check it. Check D is VIT plus half AT squared. Kristen, the units for VI. Good. Logan, the unit for T. Good. Brady, the unit of A. Good. Gabriella, the unit for T squared. Okay, what happens now, Matt? S squareds cancel. Is that the only thing that cancels? The seconds cancel. So that leaves me with meters plus meters. And Grace, if I add a number of meters to another number of meters, what do I get? I just still end up with meters, which is what I expected. So that is correct. All right, Mike, we're up to you for reading the question. Good. All right, so now we got to make our list. What do we have as a given? So Nick, how about a given? So T is 5.21 seconds. That's one of them. Winnie, something else? Is? Yeah, that's the starts from rest piece. Ian, what's my third given? Point meters. That's right. And what's the unknown letter, Talia? Yep. Okay, Bassam, I need an equation that has those letters in it. T, V, I, D, and A.
T equals VIT is 1 half AT squared.
Good. Now, we have to move it around for A. This looks a lot more complicated than it is, and I'm going to show you a trick. What is the value for VI? It's 0. What is 0 times anything? 0. So what happens to the first half of this equation here on the right? It's going to go away. So let's just ignore it entirely. And now let's just move this around. What's left? D is 1 half AT squared. Can you move that around for A? That should be a lot easier. What are you going to get when you bring the half and the T squared to the left side of this equation? How do you get them to the left side? What are they doing, the half and the T squared? What are they doing to A? What's the math operation in there? So how do you get it to the other side? You divide. D over half of T squared. What's dividing by a half the same as? Not what? No, that's dividing by a half is not the same as multiplying by a half. Multiplying by 2. So what I'm going to do is show that A is 2 times D over T squared. Now I'm going to do my substitution with units. 2 times 110 point meters over the quantity 5.21 seconds squared. All right, go ahead, get an answer, please. With proper units, sig figs, and direction. Nate, let me know when you have that, please. No, don't share with him. He should be able to do it himself. 2 times 110 divided by 5.21 squared.
They gave me 42.2. Oh, because I didn't do the square. Hold on.
Yep. Okay, how many sig figs do I need? It's 110 point meters and 5.21 seconds. Thank you. And what is the direction of this acceleration? And the units?
Wait, yeah, per second squared.
Very good. Now let's check it. And the one that we're going to check is the one we plugged into, which is A equals 2D over T squared. Ellie, does the number 2 have a unit? Nope, ignore it. Sophia, what is the unit for D? Good. And Kaylee, what is the unit for T squared? T squared. And is that what we expected to get? Meters per second squared, meter per second squared, done. Okay, number 7. Christian, go ahead and read this for us.
A race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second, 2.47 seconds. Determine the acceleration of the car in distance round.
Oh, so this wants 2 things. All right, how about a given? We're just going to create one givens list for the whole thing. Logan, how about a given?
Positive 18.5 meters per second.
Okay. Grady, another given? Yeah. Gabriella, my third given. Good. All right, let's do the first step. The first unknown in this problem, Matt, is what? Because we have 2 things unknown. What's the first one? Yep. All right, so we need an equation that we can use to help us get A that has a VI, a VF, and a T. Grace, any ideas? Okay, good. Let's now move it around for A. Mike, do you know what that equation for A is going to look like?
Yeah. Yeah, minus VI over 2.
Correct. I want you guys to notice something. Isn't that the same as what we had right here? Do you see it? It is exactly the same. So if you wanted to start with this, that would have been cool too. It's the same equation. They just have it kind of spelled out for you here. Either way. All right, let's do your substitution with units. And what I taught you to do here is to do your intermediate subtraction first in the numerator. 46.1 minus 18.5 gives us positive 27.6 meters per second over 2.47 seconds. So now you can go ahead and solve that with proper units and sig figs. Nick, when you have it, let me know, please.
I got or positive 1.2.
Very good. That's it. Let's check it over here. And we're going to check the one that we plugged into. A equals VF minus VI over T. Winnie, what are the units of VF? Good. Ian, the units for VI. Good. Talia, the unit for T. Good. And if we subtract a number of meters per second from another number of meters per second, like we did here, do you notice we still get meters per second? So what is meter per second divided by seconds the same as? Christian? No. Yeah, that's meter per second, which is meter per second squared. And that's what we expected. Okay, the second thing that we want you to solve for. Awesome. What are we looking for in the second part of this? D. All right. So let's go back to what we have in our original givens list. I do not want you to use the acceleration to solve this. Because if you messed up the answer for the acceleration, guess what happens to this answer? It will also get messed up. There is a way to do it without using the acceleration, using only VI, VF, and T. Without an acceleration, how can we get a distance? Use your reference table. There's only one equation that does not involve the acceleration. What is that equation? Nate, can you tell me? The one and only equation we have out of those 5 that does not involve a distance. Yes, which means you have to come up with the average velocity of these two. What is the average of those two numbers? Ellie, can you tell me? What's the average of 18.5 and 46.1? Yep. Positive 32.3 meters per second. Okay, so now let's come back to this. Sophia, can you move that around for D, please? Good. Now we can do our substitution with units. So the D is going to be that positive 32.3 meters per second times the time, which was 2.47 seconds. Now we're going to solve it for the distance, which is a scalar. So I don't need a direction on this answer. I just need a final answer with proper units and sig figs. Kaylee, do you have that answer?
79.8.
That's right. Now, we already did this check for that equation, and we did it back in which question? Go back through the questions we've done, and you should see that check being done in which question? Nick? Yeah, number 2. So because we've already done it, I'm not going to do it again just to save some time. If you want me to do it again for you, I will. It's the exact same thing again. You should be able to do it yourself at that point. Okay? Every time we see a new version, I'll show you how to do it. But if we've already done it once, I'm moving on. I'm going to assume that you can follow it again. All right, number 8. Oh, Christian, you read the last one. So Logan, read this one.
Rocket-powered sled for use in response to acceleration. A rocket-powered sled accelerated with speed of 444 meters per second in 1.80 seconds. And what is the acceleration? And what distance does the sled travel?
Yeah. So what they do is they actually put people in these, like, they're like bobsleds that have rockets on the back. People get loaded into them and then they fire them down to see if they can handle the acceleration. They do this with astronauts, for example, that are going to go into space because they don't want them passing out during the process of taking off and so forth. So that helps you get a given that isn't listed in the question. But like the last one, there are two things we want to find. So we're just going to make a common givens list that can be used for both parts. So Christian, how about one of the givens?
Final velocity of 1244.
Yeah. Grady, how about another given? 1.80 seconds. Don't drop the 0 or you're changing the sig figs in the problem. And Gabriella, what's the third thing that we know? Yeah, because the people can't get into that sled, the bobsled, if you will, to take off unless it's at rest. It's got to be at rest to start. Okay, let's go to the first part of this question. Matt, what's our first unknown? A. Okay, Grace, how about an equation for A? That's right. And when you do a change in V, remember that's the same as VF minus VI over T. You got to subtract in the correct order. So let's go ahead and do our substitution with units. So that is 444 meters per second minus 0 meters per second all over 1.80 seconds. Do you have to worry about subtracting the 0? No, so ignore it. Just do 444 divided by 1.80. Mike, can you tell me what you get for this answer with the proper sig figs and units and direction? Correct. And again, if you look back at number 7, there's the check for it. We did it right here. It's the same thing. See that? The check in 7 is the same check that would be used here in this question. So I'm not going to do it again. Let's go on. What is the second thing, Nick, that I'm asking you to find in this problem? The D. Again, don't use the A. Winnie, can you come up with an equation that doesn't use the A that could help us get that distance? Yeah, V bar is D over T. So Ian, what is that equation for D going to look like? Yeah, now let's come back here to those givens. You got to come up with your average of those two speeds. Talia, what's the average of 0 and 444? Yep. So now we can do our substitution with units. 222 meters per second times 1.80 seconds. And Bassam, what are you going to give me as the final answer for that distance with proper units and sig figs?
4.400.
Yeah, or without the scientific notation, 400 point. And what units? Yeah. What Bassam said is also correct. It's the same number of sig figs if we write 400 point. 3 sig figs on both. And again, I'm not going to check it because it's the same check we did back in number 2. So you're going to see a lot of the same checks. Can I go on to number 9? We'll keep practicing. The more practice we do, the easier I think this will become for you. All right, Nate, go ahead and read number 9.
A bike accelerates uniformly from rest to speed of 7.10 meters per second over a distance of 35.4 meters. Determine the acceleration of the bike.
Good. All right, Ellie, how about a given? Good. That's what from rest is telling us. Sophia, how about another given?
Is 35
Yep. And Kaylee, what's our final given? I'm sorry, the VF is what?
35.4.
Units on a velocity need to be meters per second. So that we already have. What is it? I'm sorry.
7.4.
There you go. That's your VF. That's your final speed. Now, Christian, what's our unknown letter?
Acceleration.
Lowercase a. Good. All right, Logan, you get to pick the equation this time.
BF squared equals BI squared. That's 280.
Yes. And we got to move it around for A, which I'm going to look back. I think we did this previously. Yep. In number 4, you'll see in number 4 that we moved it around for A previously. VF squared minus VI squared over 2D. So now you're going to do your substitution with units. The 0 you can forget about. And now you're going to solve that for the acceleration with proper units, sig figs, and direction. Brady, let me know when you think you have it. Okay, I agree with the positive. What did you say the number was? That has 2 sig figs. If you look at the measurements in the question, they both have 3. So you need 1 more sig fig. And what are the units again? Good. Yeah, the 0 out front doesn't count as a sig fig, Pacific rule. And we did the check step back in number 4. So I'm not going to repeat it. Were you all getting that when you did it? By the way, this is an 11-point question on a test. You want me to show you how you get your points? Why not? Because you need to understand how you're going to get graded on a question like this, which will be a show work question. 1 point for correctly listing each given with the letter. 1 point for correctly listing the unknown. 1 point for picking the correct equation and writing it down off the reference table. 1 point for correctly doing the algebraic manipulation. 1 point for doing the substitution. 1 point for the correct numerical answer. 1 point for units everywhere. 1 point for the correct sig figs on your answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 point for the positive sign on the answer. That's your direction because it's a vector. That's how you get 11 points for a problem like this. A lot of points, right? A lot of details you have to get familiar with. But if you understand what to do with the details, this becomes like, yay, I can get those 11 points, piece of cake. That's why we practice this a lot, because these kinds of questions are worth a ton. On a unit test. On a Regents exam, it's a 2-point question. But we'll discuss that in June when we get ready for that test. All right, let's go to number 10. Gabriella, you get to read this one for us.
Of the planes that use the airport, the lowest acceleration rate is likely to be 3 meters per second squared. The lowest takeoff speed would be 65 meters per second. Assuming these minimum parameters for the same point, what is the maximum allowed for the
All right. So we have another airplane taking off here. Matt, how about a given?
An A of 3 meters per second squared.
Good. Grace, how about another given? Which V is that? So that's the initial speed of the airplane taking off? VF. Good. Mike, what else do we know? It's an airplane that's going to take off down the runway. Yeah, it's 0 meters per second. 0 doesn't have sig figs, so I don't care how you write it. Nick, what's our unknown? Yeah, it's a distance value. Length is a distance. All right. Winnie, how about an equation? Yeah, take a look. This is the hardest part, I think. Picking the right equation with those letters. Notice there's no T in the list. Yep, VF squared is VI squared plus 2AD. Now this has to be moved around for D. We haven't done that one before. We've moved it around for A, so it's extremely similar. Ian, any idea what that equation for D is going to look like? That's right. Now we can do our substitution with units. So the distance is 65 meters per second. That quantity squared minus 0 meters per second, that quantity squared, all over 2 times 3 meters per second squared. Now, of course, you can ignore the 0. So on your calculator, you're going to do 65 squared divided by 2 times 3 is 6. So 65 squared divided by 6. One sig fig because of that acceleration. Talia, what do you get? Yep, 700 meters. All right, we have not checked this version of the equation, so let's do it. D equals VF squared minus VI squared over 2A. All right, Bassam, what's the unit for VF? Yep, and we need to square that quantity. Nate, what is the unit for VI? Yep, which again, we're going to square that quantity. Now we ignore the 2 because that doesn't have a unit. We just look at the A. And Ellie, what's the unit for A? The units for an acceleration are, there you go. All right, now distribute the square through those parentheses. That gives you meters squared per second squared minus meters squared per second squared all over meter per second squared. Now do the subtraction of units. When you subtract, you get the same units. And at this point, I think you can see how some things are going to cancel out. The second squareds cancel, and that square cancels with the meter in the denominator. Do you see that? So what are we left with? 1 meter is left in there, which is what we expected for our answer on a distance, meters. But that's how you get it. That's the dimensional analysis. Oh, we got time to do number 11 for sure. All right, Sophia, go ahead and read that for us.
A car traveling at 22.4 meters per second skids to a stop in 2.55 seconds. Determine the skidding distance of the car.
Okay, do you notice I circled the word stop? When you stop, you know one of these motion variables. So we'll think about that when we list our givens here. Kaylee, how about a given?
On the
Okay, that's our T. Christian, another given?
Final velocity is 0 meters per second.
Yes, when you stop, your VF becomes 0 meters per second. And Logan, what's our third given?
Probably 2.5.
We already had that. We have the time and the VF.
Initial velocity is 20.4.
Good. Grady, what's our unknown letter? D. What equation can we use here to solve this? Gabriella, any ideas? I don't have an A in my list. It's got to have a D in it. What kind of V? Yeah, so we're going to write V bar equals D over T. Now, Matt, can you move that around for D, please?
D equals V bar T.
Good. Now, you got to come up with the average of those two numbers before you can do your substitution. What's the average of 0 and 22.4? Grace, can you tell me? Yep, meters per second. So now we can do our substitution with units. That is 11.2 meters per second times 2.55 seconds. Mike, do you think you have an answer?
28.6 meters.
I agree. And we did the check back in number 2, so I'm not going to repeat it again. Let's stop there, okay? Tomorrow, I'm not going to do any of these with you. You'll see that we have 12 through 16 to get through tomorrow. Instead, what I'm going to do is I am going to put you in a group tomorrow, and you're going to work as a group to solve one of those questions. Just one, the whole thing, including the check. And then when you think you got it, you're going to call me over to check it. Make sure everybody in the group has it. And then you're going to present your solution to the class on the document camera. And then over the weekend, you're going to practice a bunch for Monday yourself, because you have to be able to do this yourself without people helping you, right? You can't have help on a test. You got to be able to do it yourself. So we'll get to practice that over the weekend and tomorrow.